Okay, welcome to the last thing that we're going to do in chapter 15. This is called titration. And what we'll say is this. Titration is a process to measure the concentration of an unknown solution of acid or base. And it works based on the principle of neutralization. If you recall, way back in chapter 14, we said that neutralization takes place when you react an acid with a base. And the products are a salt and H2O. None of these are acidic or basic in the products. That means it's been neutralized. So a titration is a method by which we take some unknown concentration of an acid or base and will react it with some concentration of base that is known, and that will allow us to determine the concentration of this unknown. That's the whole process. And to do that, we're going to use the equation from chapter 12 that says molarity is equal to moles over liters. We're going to flip this around to use moles because we know that when hydrochloric acid dissociates, or any acid, dissociates into H plus and some negative ion. We also know that when sodium hydroxide dissociates, it dissociates into sodium and sodium and hydroxide. Well, we want the H plus and the OH minus because we know that if you take one H plus and one OH minus, you get HOH, which is otherwise known as H2O. So one H plus will neutralize one OH minus and make one water molecule. All right? So we're going to do that to determine the unknown concentration of some solution. I'm going to show you exactly how it works. Here is a good example of a question you can expect me to ask. And let's notice that we have two parts to this. We have something that is known. Its concentration is given to us. And we also have something that is very specifically unknown. We're going to use the known to find out the concentration of the unknown. Let's also pay attention to the fact that we have a volume of our known and a volume of our unknown. Okay? So let's keep this equation for molarity in mind. And let's also make sure that we have a calculator. I've got my fancy one. We don't want that. That's a conversation in AP chemistry. You don't want that. But I have my calculator here at the ready. Let's turn it on so I know exactly what I'm doing. Okay? So here we go. We're going to break this down into a few steps. We're going to say 1. What, or we'll say how many moles of our known do we have? This is going to be the starting point. Okay? So the first thing we want to do is find our number of moles of our known. We are going to say moles is equal to molarity times liters. And this is in milliliters, but you're just going to move the decimal place back 3 or divide by 1,000. So if we know the concentration of our known 0.125 molar, and we also know the volume of our known 28.7 milliliters, I'm going to divide that by 1,000 to get that into liters. If you have a hard time doing that, I'm just going to take your volume in milliliters and divide by 1,000. You'll get 0.0287. Okay, so let's do this. Let's take this 0.125 molar, multiply it by 0.0287 liters. This will tell us how many moles of our known we have. So, because we have a calculator, we'll say 0.125 molar times 0.0287 liters. Here's how many moles of our known we have. We're going to round this up. We have 0.0036 moles of our known, which is something called potassium hydroxide, right? We got 0.003587. I just rounded it to 0.0036. Okay. Now, what we're going to do is we're going to take this known and we're going to dissociate it. Dissociate this known. So we know how many moles of OH minus, which is in this case, or H plus if the known was an acid, we have. Okay? So we're going to take our potassium hydroxide, and we know it dissociates right down the middle into potassium and hydroxide. We found in the first step that you had 0.0036 moles of this stuff. Well, when it dissociates, you're going to get exactly the same amount of potassium and exactly the same amount of hydroxide because there's no coefficients, there's no subscripts here. Okay? Step number 3 is that H plus is always equal to OH minus and vice versa. So if you know you have 0.0036 moles of OH minus, it's going to take the exact same amount of H plus to neutralize, right? Because right up here, remember this, we said that the ratio of H plus to OH minus is always 1 to 1. So if you know how many moles of OH minus you have, you know how many moles of H plus you're neutralizing. All right? What we're going to do is we're going to take this. We just found out how many moles of our unknown we need. We're going to reassociate our known. This is this is our unknown. This is something that we've also done before, but we didn't call it this when we were doing this. So up here it says that we have an unknown of HNO3 and that we had 25 milliliters of it. Well, HNO3 is a simple acid that dissociates into one H plus and one NO3 minus. And you already know how many moles of H plus you have because you know that this was already neutralized. So if you have 0.0036 moles of H plus, it's going to take exactly the same amount of HNO3. Okay, this is a tricky step going backwards like this, but I'll show you some tricks. We're not going to worry about that right now. Okay, finally, in the answer to our question, what is the molarity? What we mean by that is what is the concentration of the unknown. This is what we were trying to answer the entire time. Molarity equals moles over liters. Well, from this previous step, you know that you have 0.0036 moles of nitric acid. It's just how much you have. That's what you were doing in the previous example. From the information in the problem, you know that you have 25 milliliters. We're going to put that into liters. We're just going to move the decimal place back 3, or simply divide by 1,000. That's 0.025. So now 0.025 liters. This is the answer to the question, ladies and gentlemen. What is the molarity of our unknown? So 0.0036 moles divided by 0.025 liters. That means that our unknown has a concentration of 0.144 molar, and that is the answer to our question. It asks, what is the molarity of the acid solution? And you just found it. Okay?